Unsupervised learning. As we know, like in machine learning, like there are two categories: supervised learning that we had covered now, and unsupervised learning. So one thing that when we do consider the supervised learning, that whenever in our data set we are having the Y label, it means every time if the Y label is present and Y label needs to be predicted, so in that case we can do the supervised learning. Either one can do the regression, one can check it out that if we are having into the Y label the continuous values there, we can use the regression work, and we can go with the classification here when we do have multiple categories here into the Y label. So the point is that the supervised learning is used in those cases where we are having the Y label. So during the work of supervised learning, every time the output is present. Now come to the case of unsupervised learning. Unsupervised learning is used in those places where the data set is having only input values. Only X values are present. There is no Y value. No. So whenever there is no label, none of the target outputs are present there, and only X inputs are present there. So there we can use this unsupervised learning. Unsupervised learning means without any label data sets are present. So in such cases, we are left with the last option, that one is the unsupervised learning. Let's say here, unsupervised learning. So what we do when we work with this unsupervised learning, so inside the unsupervised learning, how the algorithm is going to work, there is a basic algorithm here. K means algorithm, which needs the N cluster here. N cluster means number of cluster. So this K means algorithm, which uses the N cluster. N cluster means it will start making the number of clusters which are present here into the data set. So if this is a large data set given here with the only X input values, so this K means algorithm will start making the clusters of all the nearby values by making the centroids of all those points which are having the similar like values. So here those centroid values are taken itself by the algorithm itself. Suppose here I'm having a kind of data set, for an example, any clothing data set means certain. There is a, suppose one can consider, suppose there is a manufacturing company, they are making the daily clothes, and they are making, suppose, two type of clothes in regular way, such as the smaller clothes and the larger clothes. So it means they are making the two types of clothes, the smaller clothes and the larger clothes. So it means two types of clusters are present here into the measurement data. These are all cloth measurement data. So what K-means will do, because this K-means will make the number of clusters 2 clusters. So this K-means will internally make 2 centroids, first centroid, and internally it will make randomly any other centroid, second centroid, for completion of 2 clusters. And these centroid values will start looking all the nearby values, and all the nearby values will taken by the mean. So when internal mean is calculated of all nearby value, will change the centroid also internally by the K-means algorithm. So this is centroid value. This centroid value will keep on changing. This centroid value will keep on changing till all the nearby points will move into that cluster, and correspondingly these centroid values will be keep on changing due to the new formation of the cluster with other nearby values and by taking the mean of all those values. And this cluster will stop at that position where it is finding out that all the nearby values are grouped into that cluster. Okay, so in this way, these number of clusters are created by the k-means algorithm. And suppose here I am just changing this number of clusters to 3 also, suppose for an example. So what it will do, this cluster will be grown to the third cluster also. So it will create the third cluster. So 3 clusters will be created. So it means in a data set, 3 clusters will be created. Suppose this is one of the cluster. By looking all the nearby values to first cluster, the second type of cluster, and it could be the third type of cluster by making the all nearby values, 1, 2, 3 clusters it has created by combining all the nearby values and by changing the centroid values, and these centroid values are changed by taking out a mean of all those centroid values, and it will saturate it at that place where all the nearby values are grouped into one cluster. So in this way, the k-means algorithm works under root of the unsupervised learning. So let's see here. Unsupervised learning is a technique of data segmentation that partitions the data into several groups based on to their similarities. So wherever it is finding out the similar values, it is going to be grouped here. This one, or one can see this one. Clusters are the aggregation of similar objects that share the common characteristics. We can determine the complexity of the clustering by the number of possible combination of the object. And the complexity of the cluster depends on to their number. So certain applications are present such as marketing. In the area of marketing, we use clustering to explore and select customers that are potential buyers of the product. Into the retail industries, it make use of cluster to group the customers based on to their preferences, styles, choice of wear, as well as the store preferences. Into the medical diagnosis application, industries make use of clustering algorithm to facilitate efficient diagnosis and treatment of their patient, as well as the discovery of new medicines as well. Let's see now how to make this one. So we are having the k-means algorithm for that one. So for making the cluster, we need certain libraries to be loaded, and those libraries are like tidyverse, cluster, factor extra, grid extra. All these libraries are required to make this k-means cluster. So here, suppose here I'm randomly taking any data, certain USA arrest data is there. Here I'm putting this data here into the k-means algorithm, which is a clustering algorithm, unsupervised learning algorithm. And here I want to make 2 clusters along based on this data. And let's see how it works then. So suppose here I'm just loading all this library. First of all, I have to load this library. Okay. And then I have to call this one. So I'm just running it now, right? And let's see it here. I'm just running it here. It is just loading all these libraries and running it. So it has executed it. Now let's see. Basically, I want to plot this one. So here, there is a FBIS cluster. This will assist me to make the plottings also, internal plots also. Okay, of all those clusters here. We can see here, this plotting, it is just making the two clusters here. One can see here two cluster, the cluster 1 and the cluster 2, here it is creating with this center is equal to true inside the k-means algorithm. So here it is making the two cluster based onto the data. Okay, and if we increase this one, so means suppose here centers is equal to, that's why it is making the two clusters only. And if in case suppose I run this one where I need the 3 clusters, okay, so it will start making the third cluster also. We can increase this cluster, suppose that I need a 5 cluster, so it will make the 2 more clusters, okay, by finding out the nearby values here. So in this way basically it creates the cluster here. So one can see that how the supervised learning algorithm works here. So in this way, this one unsupervised learning algorithm just make the clusters with the help of k-means, and it finds out all the nearby values. That's all with the unsupervised learning. Thank you.